Welcome aboard. Today, we are exploring a truly transformative shift happening in software development.
Indeed. We're looking at some fascinating material today.
We are examining an insightful new release, one that details the transition from, well, traditional coding methods to what we might call AI-era development.
And interestingly, this extensive content we are reviewing was itself generated by an AI.
That's quite something. It aimed to provide a comprehensive look at how software creation is changing. Our goal here is to extract the most important knowledge for you.
We want to highlight some perhaps surprising facts and certainly the practical applications.
So you can quickly become well-informed on this really crucial topic. We will proceed at a professional and friendly pace, ensuring every concept is clear.
Absolutely. This material outlines just how profoundly artificial intelligence is reshaping the roles of developers.
We'll explore the nuances of concepts like vibe coding and AI-assisted engineering.
Our aim is to distill the core insights from these sources, providing you with a clearer understanding of this evolving landscape.
Let's start with the preface of this material. It immediately introduces a profound shift.
It does. It talks about vibe coding,
Describing it as the art of collaborating with AI to create software.
which transforms developers, moving them from solely writing lines of code into becoming product visionaries and orchestrators.
It sounds like a revolutionary change in how we approach our work, truly.
It really is. What's fascinating here is the idea that AI takes on much of the, let's say, heavy lifting of coding itself.
And this allows developers to elevate their focus to higher level concerns.
Exactly. Things like ideation, overall design, and more complex problem solving.
The text even suggests we might soon be able to, and this is quite a statement, forget the code even exists.
And simply build by clearly describing our needs. It's a powerful concept.
This could potentially make the idea of a 10x engineer maybe even a 100x reality in terms of raw productivity.
Well, what is truly insightful, I think, is not just the scale of that productivity, but the profound shift in what that engineer actually does.
So it becomes less about the raw coding output itself.
Precisely. And more about strategic problem solving and vision. That seems to be the real game changer highlighted here.
That focus on strategic vision is compelling. But this shift, it impacts different experience levels in distinct ways, doesn't it?
It does, and the text points this out clearly.
For senior engineers, it suggests AI becomes a tool for things like rapid prototyping.
Yes, and generating basic implementations, exploring various options, and automating routine, perhaps tedious tasks.
But what about less experienced developers?
That's where a critical point is made regarding junior developers. They face a significant risk, according to this material.
A risk of what, exactly?
Well, they might accept incorrect or perhaps outdated solutions from the AI.
Without realizing the potential issues.
Correct. They might overlook critical security or performance problems, struggle to debug the AI-generated code effectively.
And potentially build fragile systems they don't fully understand underneath.
Which raises important questions about the foundational learning process for new engineers.
And it underscores the absolute necessity of human oversight, regardless of the tools.
Absolutely. So, with all this talk of AI taking on the heavy lifting, it is easy to wonder about the human role going forward.
But the text seems to strongly emphasize that our part isn't just vital, it's actually evolving into something irreplaceable.
What are those core human responsibilities that AI simply cannot touch, at least not yet?
Well, the human element remains absolutely vital. We are the ones who ensure the architecture is sound, for instance.
We debug the most complex, the truly thorny issues.
And we judge code quality beyond merely confirming that it runs. There's more to it than that.
Much more. We also bring that crucial user-centric thinking to the table.
Ensuring that the software genuinely works for people in a meaningful way.
So developers become curators, editors perhaps, of the AI output.
Aligning it with real-world needs and establish high standards of engineering.
Looking ahead, the material anticipates even more abstract ways of building software.
Such as vibe designing. Through graphical interfaces, maybe.
Potentially. And perhaps less reliance on generic libraries as AI generates more specific, tailored code for the task at hand.
The success of this future, it suggests, will hinge on human creativity.
And distribution skills, the ability to harness network effects.
Because the difficulty of the coding itself, the mechanics of it, will be significantly lower.
The focus truly shifts towards innovation and higher level strategy.
Okay, with that big picture established, AI is a powerful new partner. So let's zoom in a bit.
Let's look at how this partnership actually works in practice day to day.
The text highlights two very distinct philosophies or approaches when it comes to bringing AI into the coding workflow.
One is that vibe coding we mentioned earlier.
Described as a dramatic departure from traditional programming, the focus is really on speed and exploration.
With minimal manual effort, it's almost like, as you said, a fast-forward button for certain tasks.
The other philosophy is termed AI-assisted engineering.
Here, the developer remains firmly in control. The human is the driver.
Using AI more like a co-pilot for specific tasks across the software development lifecycle.
Things like AI-powered autocomplete, intelligent bug detection, or maybe generating very precise test cases.
So under vibe coding, a developer might continually accept AI suggestions, perhaps without reading every single change.
Or using AI to fix errors simply by copying and pasting error messages into the AI tool.
It sounds incredibly fast.
It does allow for incredible speed sometimes. Boilerplate code, common bug fixes generated in seconds.
Potentially compressing days of work into hours, as the text suggests.
However, the speed comes with significant risks. We need to be clear about that.
The text gives an example, I believe, of an AI-generated user login system.
Yes, one that might inadvertently use simplified encryption or perhaps known vulnerable libraries.
And deploying such code without deep human inspection would be highly risky.
Definitely. Production code needs to be fully understood and trusted by the development team.
Now, in contrast with AI-assisted engineering, the example given is a React developer building a dashboard.
That's right. In this approach, they would first write a very clear specification,
Defining the component's responsibilities, its API, how data should be fetched, the styling requirements.
Only then, after that detailed spec is done, do they use AI to generate the skeleton code.
Based on that precise description.
This structured approach helps ensure the AI's output aligns precisely with the project's needs and, importantly, the existing design system or architecture.
The text offers a useful metaphor here, I think.
Vibe coding is compared to a high-speed exploratory vehicle great for quick discovery, finding new paths.
While AI-assisted engineering is more like a reliable train on a well-defined track.
It requires more planning up front, but it's much safer for reaching clearly defined destinations.
And the recommendation seems to be that intermediate and advanced developers should ideally master both approaches.
And be able to choose the appropriate one based on the specific task at hand. Is it exploration or is it reliable delivery?
That makes sense. And as we consider these two approaches, one thing becomes incredibly clear.
The quality of the collaboration hinges entirely on how well we communicate with the AI.
Which brings us to a fundamental new skill for developers, what the material calls the art of the prompt.
The central idea here is that prompts are, in a sense, the new source code.
How you communicate your intent to the AI directly impacts the quality of the code it generates.
A vague prompt will almost certainly lead to incorrect or irrelevant code.
While a clear, specific, well-crafted prompt can yield a spot-on solution, maybe even on the first try.
Being specific and clear is presented as a golden rule.
For example, instead of a vague instruction like, write me a sorting function,
A good prompt would specify the language, say Python.
it would include the desired function name, the structure of the input data.
The key to sort by, any documentation requirements, maybe even how to handle edge cases like missing values.
This level of detail leaves far less room for the AI to guess or make potentially wrong assumptions.
And iterative refinement is equally crucial. It's not always a one-shot process.
You should treat your interaction with the AI more like a conversation, a continuous feedback loop.
Review the code it generates, identify what might be missing or incorrect.
And then provide precise feedback or perhaps a refined prompt to guide it better.
The text demonstrates this with an example of a buggy Node.js function.
Showing how a precise prompt, importantly including the exact error message and the expected output, helps the AI correctly identify and fix an off-by-one error in a loop.
It really is about guiding the AI towards the correct solution.
Now let's pivot slightly to one of the most widely discussed aspects of AI in development.
This is what the text calls the 70% problem.
It suggests that AI is astonishingly good at certain tasks, particularly producing boilerplate code and routine functions.
Getting projects, let's say 70% of the way to completion, very, very quickly.
That initial burst of progress can feel almost magical sometimes.
It really can. This 70% often includes the straightforward patterned code.
What the text refers to as accidental complexity. Parts that aren't inherently difficult conceptually, but just verbose or repetitive to write.
However, the final 30%, that's where the human element becomes critical.
This includes handling tricky edge cases, refining the overall architecture.
Ensuring long-term maintainability and tackling truly novel problem-solving that requires genuine invention.
AI, it seems, struggles with creating fundamentally new abstractions or taking responsibility for those big architectural decisions.
It's currently more adept at remixing and applying existing patterns rather than inventing truly novel solutions from scratch.
The real eye-opener here, perhaps, is realizing how much of our historical engineering effort was actually spent on managing that accidental complexity.
It forces us to reconsider, maybe even redefine, what true engineering skill looks like in this new era.
Moving beyond the purely mechanical aspects to the truly conceptual and strategic ones.
That's a fascinating insight. So, for integrating AI effectively into the workflow, the text outlines 3 useful patterns.
First, AI as first drafter, where the AI generates an initial version and a human refines it.
Second, AI as pair programmer, involving continuous collaboration between the human and the AI tool.
And third, AI as validator, where AI analyzes human-written code to spot potential issues like bugs or style inconsistencies.
Each pattern obviously has its own strengths and is suited to different contexts.
The material also introduces some important golden rules for responsible AI coding practices.
Yes, things like using AI to expand your capabilities, not to replace your critical thinking. That's number 1.
Coordinating upfront with your team about how and when AI tools will be used.
Treating AI usage as a normal part of the development conversation, not something hidden.
Isolating AI-generated changes in version control, maybe with separate commits for clarity.
Ensuring all code, whether human-written or AI-generated, undergoes rigorous review by humans.
And critically, perhaps the most important rule, never merge code. You do not fully understand yourself. You own it.
Absolutely. Taking responsibility is key.
So moving beyond that initial 70%, how do human engineers maximize their contribution? Where do we add the most value?
The text suggests senior developers should increasingly act as architects and perhaps an editor-in-chief.
Translating complex requirements into effective prompts for the AI.
And then rigorously vetting the AI's output for quality, correctness, and alignment with the project goals.
This chat-oriented programming style, as it's sometimes called, could allow teams to tackle more ambitious projects.
By abstracting away much of the rote coding effort.
At the same time, human engineers must continue to cultivate deep domain mastery and foresight.
Understanding the business needs, interpreting user feedback, anticipating the potential long-term impacts of technical decisions.
And soft skills, leadership qualities, become even more vital.
Communicating effectively with stakeholders, leading design meetings, mentoring junior engineers, these human-centric skills are irreplaceable.
For mid-level and junior developers, the advice is quite clear. Learn the fundamentals deeply.
Master algorithms, data structures, understand how systems truly work under the hood. Don't just rely on AI for instant answers.
It also recommends practicing problem-solving and debugging without AI assistance periodically.
To build genuine confidence and intuition, and importantly, to avoid skill atrophy in those core areas.
A strong focus on testing and verification is also emphasized, especially for junior developers.
Making writing tests a core habit, particularly for AI-generated code, is crucial to rigorously challenge its correctness.
Building an eye for maintainability, understanding good code structure, and proactively refactoring AI output are also key skills.
It sounds like, in a way, we're becoming code whisperers for the AI.
Guiding it carefully and ensuring it doesn't wander off track or create problems down the line.
That's an excellent way to put it. Now, taking these concepts into real projects.
The material highlights how AI can really turbocharge prototyping.
Rapidly turning ideas into working models much faster than before.
AI coding assistants seem to excel here, quickly producing functional code from minimal input.
Like describing a user interface mockup in natural language and letting the AI generate the initial HTML, CSS, or maybe React components.
Prototyping prioritizes speed and experimentation over perfectly polished code, of course.
So throwaway code is often acceptable in this phase,
provided there's a clear plan to refactor or rewrite the critical parts later for production use.
The process usually involves iterative refinement, generate an initial version, then tell the AI precisely what changes you want step by step.
But the transition from that rough AI-generated prototype to production-quality code is highlighted as a critical juncture.
This requires a definite shift in mindset from rapid prototyping mode to a more disciplined engineering approach.
Human developers must step in to review the architecture thoroughly.
add proper structure, improve the overall code quality, address performance and security.
with AI potentially assisting in making these specific improvements, but under human direction.
The text includes a helpful case study, a developer building a service to convert CSV files into charts.
She uses AI to create the initial prototype very quickly.
But then, crucially, she hardens the backend with proper authentication.
Refactors the front-end code into a well-structured React application.
Writes comprehensive unit tests, interestingly, querying the AI for potential edge cases to test.
And finally, polishes the user interface based on design principles.
This human oversight and intervention are presented as indispensable for reaching true production quality.
This idea extends naturally to building full web applications, not just prototypes.
AI can assist significantly with project scaffolding.
Setting up the initial build tools, the file structure, managing dependencies for both front-end and back-end.
For front-end development, as we touched on, AI can create components from natural language descriptions.
For example, a React total list component with very specific functionality outlined in the prompt.
It can also help with styling, perhaps by describing the desired look and feel.
And assist in integrating APIs and state management logic, like fetching data when a component mounts.
Similarly, in back-end development, AI can help implement API endpoints.
Like a GT to-dos route, for example.
It can assist with integrating databases, perhaps using ORM's object relational mappers to simplify database interactions.
And help add the necessary business logic and validation rules to those endpoints.
It can also be useful for generating initial API documentation or writing basic tests for the back-end code.
Full-stack integration is noted as crucial, ensuring the front-end and back-end communicate correctly.
That their contracts, their APIs, align perfectly.
Best practices suggested include using AI primarily for the boilerplate code,
While writing the core custom logic yourself, where the unique value lies.
tackling development tasks piece by piece, rather than asking the AI to build the entire application at once.
Prompting the AI specifically for code quality improvements or adherence to certain standards.
And perhaps using AI as a sounding board, cross-checking different design approaches to ensure consistency.
And of course, thorough testing and validation are paramount for any AI-generated web application components.
This includes unit tests, integration tests, end-to-end test areas where AI can often help generate the test code itself.
But also, manual exploratory testing by humans, rigorous code reviews, and dedicated security audits remain vital.
The text even suggests that AI might make it easier to achieve better test coverage.
Potentially leading to more robust and reliable code overall, if used correctly as part of a disciplined process.
Moving beyond just functionality, critical aspects like security, maintainability, and reliability are absolutely paramount.
Speed and productivity mean very little if the resulting software is vulnerable, prone to crashing, or becomes impossible to maintain over time.
The text points out common security pitfalls in AI-generated code.
Such as improper handling of authentication and authorization.
There's an example showing an insecure login route, perhaps directly comparing plain text passwords.
Or revealing too much sensitive information in error messages, which can help attackers.
But the AI, if prompted correctly with security requirements, can often fix this.
For instance, using robust password hashing like bcrypt, a strong industry standard method.
And providing generic, uninformative error messages to prevent information leakage.
For security audits, the text mentions using automated scanners, known as SAS tools.
That's static application security testing tools that scan your source code for known vulnerabilities before you run it.
Things like ESLint plugins for JavaScript security rules, or Bandit for Python code.
Alongside these tools, human code review with a specific security checklist is essential.
Focusing on areas like data input-output validation, interactions with external APIs, and database access security.
Penetration testing and adding security-focused unit tests are also part of a robust strategy.
Building effective test frameworks is highlighted as key for overall reliability.
The text emphasizes embracing automated testing early and often.
Integrating it deeply into CI/CD pipelines, continuous integration, and continuous deployment.
This includes a mix of unit, integration, and end-to-end tests.
Plus, load testing, performance testing, and specific tests for error handling scenarios to ensure the system is fundamentally dependable.
Performance optimization is another area where AI-generated code might not be optimal out of the box.
Human developers need to carefully consider algorithm complexity, big O notation,
Memory usage patterns, effective caching strategies, and database query optimization.
AI can assist in suggesting optimizations in these areas, but it usually requires very specific prompts and human judgment to identify the real bottlenecks.
And for maintainability, ensuring the code can be understood and modified easily in the future.
Consistent coding standards across the team are vital.
Using established architectural patterns that promote modularity and separation of concerns.
Engaging in continuous refactoring to improve code structure over time.
And building in resilience, perhaps with sensible fallbacks for when external services fail.
Code reviews are absolutely crucial here, with reviewers focusing not just on logic, but also on clarity, style, security implications, and whether the code adheres to team norms and established best practices.
The text also briefly touches upon another critical aspect concerning generated code: ownership and potential intellectual property risks.
It warns that AI output might statistically contain snippets of code that resemble material from its vast training data.
So, if a large chunk of AI output looks suspiciously like a verbatim copy of known code found elsewhere,
Caution is advised. It might require running similarity checks.
or perhaps transforming the code significantly, or ensuring proper attribution if the source requires it to comply with open source licenses.
The legal landscape for AI-generated intellectual property is still very much developing and requires careful navigation and awareness.
Regarding reliable deployment practices,
The text advocates for automating CI/CD pipelines as much as possible,
using infrastructure as code tools for consistency,
employing staged rollouts, like canary releases or blue-green deployments, with clear rollback plans.
testing changes even in the production environment carefully, and conducting regular system audits.
And despite all the automation, the human element, including skilled on-call engineers who deeply understand the system, remains absolutely essential for handling unexpected incidents.
Looking even further into the future, the material introduces the concept of autonomous background coding agents.
This sounds like the next evolution beyond the current Copilot style assistants.
Unlike copilots that work synchronously with the developer, these agents are envisioned to operate independently, more like background workers.
You might give them a high-level task, like improve test coverage for this module or update these dependencies.
And the agent would work through it autonomously, eventually generating a pull request for human review.
Almost like delegating a task to a diligent, albeit artificial, junior developer.
The text draws a distinction here. It's the difference between a copilot, which is always awaiting your input, and an autopilot, which can navigate on its own for periods.
These agents would operate at the project level, potentially making coordinated changes across multiple files or modules.
And ideally, running tests automatically in a safe sandbox environment before proposing the changes.
They aim to simulate a methodical developer's workflow. Understand the request, plan the steps, execute the code changes, test the results, and report back.
These agents offer the promise of high autonomy, operating asynchronously.
Freeing up human developers from more routine micromanagement or task execution.
However, they also introduce new challenges. How do you coordinate multiple agents working on the same code base?
How do you manage the potential brittleness of their sandbox environments?
And could they amplify the code review bottleneck by producing a very high volume of proposed changes?
Delegating tasks to these autonomous agents requires a significantly higher degree of trust.
And careful consideration of the security implications. A compromised or misdirected agent could potentially commit and deploy problematic code if not properly supervised.
Best practices suggested include strategically selecting tasks that are well-suited for agents, perhaps repetitive refactoring, test generation, or dependency updates.
And building robust feedback loops and clear review processes are essential.
Finally, the material explores the future of programming languages themselves.
Posing the question, will natural language effectively become the new primary programming language?
The trend does suggest that developers might increasingly specify their intent in high-level human language.
And AI tools will then translate that intent into executable code in traditional languages.
This doesn't necessarily mean traditional programming languages like Python, Java, or C++ will vanish entirely.
Rather, a layering effect seems likely to emerge.
Natural language might be used for high-level orchestration and defining overall goals.
While existing programming languages provide the necessary tools for fine-grained control, optimization, and debugging when needed.
Developers of the future might need to be effectively bilingual.
Fluent in human language to communicate effectively with AI systems.
And also fluent in the underlying technical concepts in programming languages to verify, debug, and refine the AI's output.
AI will likely continue to raise the abstraction level of programming.
Allowing developers perhaps to define new abstractions or domain-specific languages more easily on the fly.
However, understanding how the code actually works, how computers execute instructions, how systems interact, that foundational knowledge will remain crucial.
Even if AI handles much more of the writing of the code itself, human oversight depends on this understanding.
So, wrapping this all up, what does this really mean for you, the listener, the developer?
This exploration of AI in software development highlights a very clear message, I believe.
AI is emerging as an incredibly powerful amplifier for engineers, a force multiplier.
It handles many of the repetitive, time-consuming tasks, accelerating the development process significantly.
But this is where it gets truly interesting and perhaps reassuring.
That crucial final 30%, the part that AI currently struggles with.
System design, critical thinking, complex debugging, making key architectural decisions, understanding the nuanced why behind software choices.
That firmly remains in human hands. Your creativity, your intuition, your thoughtful engineering judgment are what transform raw AI output into truly valuable, robust software.
The ultimate craft of software engineering isn't just writing code that works.
It's about writing code that works well, reliably, securely, maintainably, efficiently in the complex real world. That responsibility, that craft, always belongs to the developer.
We certainly encourage you to explore this topic further on your own.
To gain even deeper insights into this transformative shift, we definitely recommend reading the full content discussed today.
There is always more to learn and integrate into your daily development practice as this field continues to evolve rapidly.